to be a little bit more complicated. Matrices can only be multiplied if the number of columns in your first matrix is equal to the number of rows in your second matrix. The first thing that I want you to do with a matrix multiplication problem then is to start off by writing what the size of the matrix is. This first matrix is what size? 1 row by 3 columns. 1 by 3. This second matrix is what size? 3 by 1 rows, columns. 2 matrices can be multiplied if and only if, let me color coordinate this so it matches up, if the number, oops, didn't take it. I want this, oh, I accepted the background color. I want to be the line color. There we go. The first thing you look at is this. If those two values adjacent to one another are not equal, then the operation of multiplication is not defined. You can't do it. Not even God is that good. Actually, he's probably better. He could probably do it. He'd find a way to do it, okay? It's not a defined operation in our number set. So that's the first thing you look for. But that's not the only thing you look for, because these outside numbers will tell you what the size of your result is going to be. If you multiply a 1 by 3 matrix by a 3 by 1 matrix, your result is going to be a 1 by 1. 1 row, 1 column, in other words, only one number. That's it. To multiply matrices together, every row is multiplied by every column, but each item is used only once. So let me come back and put that into an actual statement there. The process. Every row is multiplied by every column. Each element is used only once. So what that means is first elements of matrix A, I'm going to use matrix A and matrix B as my matrices out here. It's easier to keep track first and second. First elements of matrix A first element of row 1 of matrix A is multiplied by the first element of matrix B, column 1. Second element of row 1 is multiplied by second element of column 1 in matrix B. Element. Et cetera, et cetera, et cetera. Okay, those words look really nice. They're really strange, but it doesn't necessarily tell you much about what goes on here. So let me bring this stuff down a little bit, get it out of the way. So we can make more sense out of it. So here's the mechanism. All multiplications are rows by columns, regardless of how many rows and columns you have in your matrix to begin with. You just keep repeating that operation until you've multiplied everything. So this is an easy one. The first one's an easy one because we have only one row and one column. So that means the first element of matrix A is multiplied by the first element of matrix B. First element of the row is multiplied by the first element of the column. 2 gets multiplied by 3. And that is then added to second element is multiplied by the second element. Negative 3 is multiplied by positive 5. And that is added to third element by third element, 4 being multiplied by a negative 1. So that means that we will have 6 added to a negative 15, added to a negative 4, which will leave us with a negative 13 as a result. Our matrix is going to have a final result of a negative 13. Now I can already hear the question coming. Why are we adding those things together?